Hi, I'm Bob Tabor with LearnVisualStudio.net. Up to this point, we've written all of our code inside of the module called Module 1. And I briefly said in an earlier lesson that a module is basically a class with superpowers. More about modules a little bit later, but we need to talk about classes because, first of all, just about everything in the .NET Framework base class library and inside of the applications that you'll build are comprised of classes. And then secondly, as you begin to build larger applications, you'll need to start thinking in terms of classes to create flexible, reusable libraries of code. So what are classes exactly? Well, near the beginning of the series, I described classes as a container for related methods. And that was a bit of an oversimplification, but hopefully it served as a working definition. You can already see that I have open a project called Simple Classes. Go ahead and take a moment to pause the video, create this project so you can follow along. So to start off in our conversations, we use the console class, and we were able to access the related members of the class like the readLine method and the writeLine method through the use of the period or the dot, and we said that that was the member access operator. So that gave us access to the related methods that have something to do with the console window. And to tie that together with the thought from another lesson where we talked about simple helper methods that we created, we said that new methods should be defined inside of the body of our module. I was very particular about where you needed to define that method. It couldn't be inside of the submain, and it needed to be kind of here. Let me get rid of this. Inside of, or kind of a child of our module 1. So we started defining our helper method right here, approximately line 8 or 9. Now, truth be told, in both of those lessons, I was intentionally oversimplifying the explanation of classes because as you're going to come to learn, virtually everything in Visual Basic and in the .NET Framework is either a class or it's somehow related to a class. And that's really the purpose of this lesson. I'm not really expecting you, after watching this lesson and even the lessons that follow, to go out and create your own library of custom classes. Now that's a skill that takes some time to master, but rather what I really want you to be able to do is to better understand how the classes are utilized within the .NET Framework base class library by understanding what a class is, how you create one, and how you use one. Hopefully that will help build a mental model that you can use going forward to work with all those classes in the .NET Framework base class library that we won't be able to cover in this series of lessons because frankly there are just too many of them. And yes, someday perhaps you'll be skilled enough to design and implement your own code libraries so that other developers can use them in their applications. This is a common a way of designing large applications that you might build for a business, for example, as a means of sharing code that encapsulate the business rules for a given company. So as we get started, the truth of the matter is that I couldn't possibly cover everything there is to know about classes because it's such a vast topic. If you really want to learn more about the power of classes, then you're going to want to learn more about specifically object-oriented programming. That's a topic for another day, but use those keywords to find some good resources online, like on MSDN or Microsoft.com or my site, LearnVisualStudio.net. Okay, so we have a project here called Simple Classes, and suppose that I wanted to create an application that worked with cars. Suppose I have a car lot business, and I need to keep an inventory of all the cars that are for sale on my car lot. So to keep all of the related information about a single car into one code container, I may want to create a car class. So in Visual Basic, there are a number of ways to do this. The simplest way, in my opinion, is to right-click on the project inside of the Solution Explorer. Right-click and select Add Class. And we'll make sure that class is selected here in this main area of installed templates. And I'm going to change the name from class1.vb to car.vb and click Add. All right, and so you can see that automatically we have loaded up into our main area the car.vb file, and defined inside of it is a public class car. So this tells the compiler, the Visual Basic compiler, what type of code block that we're attempting to create. And so we gave this car, or this class, the code block, the name car. Now, what we define inside of the class will be the members of this class. We've already seen how to create helper members in an earlier video, but we put those in a module. The process of creating methods inside of a class is exactly the same. In addition to creating methods, however, we can also create something called properties. Now, methods and properties, just a quick side note, classes can contain other members as well, not just methods and properties. But these are the two of the most popular members of classes. And you'll learn about some others as you continue to work with Visual Basic. Those are a little bit beyond the scope of this lesson. Let's just keep it simple for now with methods and properties. So in this lesson, we're going to create 4 properties in our car class. Things like make, model, year, and color. Attributes that we normally use to describe a car, an instance of a car, a single car. But they're common across all cars as we think in our mind, what is it that makes a car, okay? So think of these as attributes of a specific car on our car lot. And then later on, we're going to create a method inside of our car class as well to perform or do something. So a property defines an attribute of an instance of a class. We can then set the value of an attribute inside of our code, or we can retrieve the value of an attribute in code like we'll do in just a moment. So in a sense, we're defining special variables that when combined together inside of a class describe the attributes of an instance of our class. And there are several different ways to create a new property. I'm going to show you probably the easiest way to do it, at least the least confusing way to do it. So here I've created a property called make. It's a simple property that's of type string. And just to let you know, I'm creating a shortcut version of a property here. It's actually called auto-implemented property. All right. If we were to create the same property using the full syntax, we would do something like this. In fact, we can borrow a code snippet to kind of type out all the pieces for us. Here I typed in the word prop tab tab, and when I did, it created a full code snippet to define a property. And here I would just change this to underscore make as string make. All right, and so this would be a larger or the more complete example of a property called make for our car class. Let's just forget that this even exists for now and just keep it simple. And what I'll do is use this same auto-implemented property format to create 3 other properties as well. These are some basic details about a specific instance of the car class, and we'll show you what we'll do with that in just a moment. But it's important to understand what we've done here. We've defined a data type, just like a string, just like an integer. Okay, this data type is a little more complex because it doesn't hold just one value, it holds multiple values that are kind of related together to describe a single car. It has more pieces of information, but they're all related to the notion of a car. So I've created a blueprint of how to create a variable of type car. And now what I can do with this blueprint is to create instances of the blueprint or of the class. Just like you take one blueprint for a house and you create multiple houses from that same blueprint, you can do the same thing in code. Here, let me save everything first. So I'm going to go back to the module1.vb tab, and inside of my submain, I'm going to create a new instance of the car class. All right, so this is one way to create a new instance using Visual Basic of our car class. And what we can do now is access the members of the car class by typing its name, my new car dot. So this is a specific car, and we can set its make equal to Oldsmobile, for example, and so on. We'll get to that in a little bit in just a moment. We'll add some more. But this is, as I noted in a previous video, this is just one way to create a new instance of a class. Let me comment that out and show you the newer style. My new car as new car. All right, and these two lines of code in 5 and 6 are equivalent. This is just a little shorter. All right, so back to filling in some details about our car here. Let's just walk through this. First of all, an instance of a class, like we've created right here, an instance of a class is known as an object. Now, an object is not a class, and a class is not an object. Although sometimes you hear people mix those terms or use them interchangeably. I have accidentally confused those terms myself at times. The class is the blueprint. Once you create a new instance of the blueprint off the assembly line, if you will, it's called an object from that point on. So what we've done is created in memory a space large enough to store a new instance of the car class. And now we're going to start filling in, beginning in line 8, 9, 10, 11, we're going to start filling in the details of one specific instance of car, and we called that instance my new car. So did you notice as I was working through this example, my new car, I got full IntelliSense. It understood that my data type car has a color member, a make member, a model member, and a year member. Pretty cool. Now there's one other thing that you might see as you're looking at other people's code. Whenever they have a code passage like this where they're filling in the details or the properties of a given class, they might use a different syntax, a shortening syntax. Instead of having to type my new car every time, they can do something like this. With my new car, then they'll just use the period on the keyboard, and you can choose make equals olds, model equals Cutlass, year, and you can see how this is a nice convenience so that you don't have to type out the full name of the class every time, and that's unique to Visual Basic. All right, but let's comment that out for now. All right, the gist of this little passage of code here is that I set each of the properties of the new instance of car to their appropriate values for that given instance. It represents one car on my car lot. Okay, so this is a really tiny example, right? And all I've done is just hard code the values in my submain of a console window class. If this were a real application, I'd probably present some sort of graphic user interface to the user, and I would ask them, hey, tell me about the newest car on your car lot. And so they, on a web page, they'd be able to type in, you know, the make, the model, the year, and so forth. Or maybe it's a Windows form that we display to capture that information from the user. Or maybe it's a phone application like the Windows Phone 7 where they'd be able to type in all those values and hit submit. And then I would take whatever values that they typed in and I would save them as attributes of a new instance of the class. Now that I have all of those attributes in my object, I would then save those to a file somehow or save those into a database somehow. But obviously we need to keep this example simple. I just wanted you to understand the context in which something like this would be used. Here I'm hard coding. You probably wouldn't use it exactly that way. All right. So this is a good example of setting the values, much like we would set the value of a variable. We do kind of the same thing here with our car. And we can also retrieve the values that were set. And so let's write a simple line of code like this. Console.writeLine. Okay, so just like we were able to set the value of each of the properties, we're also able to retrieve or get the values of each of the properties, like we're doing here in line number 20, where we're just retrieving them and inserting them into a string with some replacement characters. Let's go ahead and just make sure that this actually works. And it's as you would expect. Okay? So the next important thing for you to realize is that when you create a new class, you're actually creating a new data type. Just like any other data type, like we said earlier, like a string or an integer, it just happens to have a few more parts or pieces to it. It's a bit more complex. But you can use that data type anywhere in the rest of your application. So we've already seen how to get and set its values, but what if we wanted to create a helper method here that would accept as an input parameter the data type of car? So let's do this. And so what this little helper method is going to do is allow us to pass in a car, and there will be some super secret formula here that will look up the car online, maybe get its Kelly Blue Book value, and then return that value in the form of a double data type, which is just kind of like an integer, except it has values after the decimal place. So you can have both whole values and fractional values. And in this case, we'll just hard code this because that's not really the focus of our lesson. What we really want to do is focus on the fact that you can pass in the data type of car into a helper method. So let's do this. Console.writeLine, and then we're going to call determine market value, and then we're going to pass in my new car. Now let's see what gets printed out to the window. 100, just like we would expect. Okay, so again, the key notion here is that when we define a car, we're defining a data type. And that data type can be used in other places, like used as input parameters, or even we could return a car from here if we wanted to. Now, by changing that, we've changed the signature of this, and this line of code would break. So let's change that back. But I just want to impress on you that it's a data type just like string, integer, double, date, anything else that we could have used that were already defined for us in the .NET Framework base class library. Okay. All right, so moving on, we said previously that classes are made up of both properties and methods. And so let's just steal this implementation that we created here. I'm going to first of all copy this, and then I'm going to use my comment out selected lines to kind of get rid of the helper method. I'm going to go over to my car class. I'm going to paste this in, and I'm actually going to add the word public here, and I'm going to remove the input parameter, and instead I can now just reference the existing instance of this class. So say I needed to pass into this super secret formula to make the model, the year, and the color. I don't have to pass it in because it's already a member of this class. All I need to do to access these properties is to use a keyword called me. So now I can use me.make, and I could retrieve that and pass it to something else. I can use me.model. All right, and so it would refer to the instance that we have already that we're already using and working with here. Now to call that, I'm going to do this: console.writeLine my new car dot determine market value. So let's run the application now. And you can see we get the same result because we stole the body of that method. But the key idea here is that we can call this method using the member accessor, and when we're inside of the body of a method, we can reference the other properties defined in the method, or even other members like other functions that are defined, other methods defined inside of the body by using the me keyword. Okay? So wrapping this up, this is a very simple example. It was simple because I chose an example that's concrete. I chose a car. A car is easy to conceptualize and to represent in a class because it's tangible and it has a real-world equivalent. But remember that what we're really trying to accomplish here in this lesson, I want to give you a better understanding of how classes are constructed and utilized within the .NET Framework-based class library. So as you begin to build applications that rely on the .NET Framework-based class library, you're going to find that many of the classes do not have real-world equivalents. In other words, the classes represent things that are more conceptual in nature. For example, I might work with a class in the base class library that represents a connection to the internet. I might work with a class that represents a stream of data, like we talked about earlier, a pipeline of data that flows from one place to another. I might work with a class that represents a span of time. These don't have real-world equivalents. So this car example is atypical of the kinds of classes that you'll wind up working with. I simplified it as a means of helping you to think in terms of properties and methods. Okay? So as you begin to mature as a software developer, you might be called on to create a library of classes specifically for the company that you work for that encapsulates all the business rules. For example, how to handle promotions or tax in given countries, or how to handle inventory outages. All these things that the organization needs, you'll be called on to write code to handle, and so one of the best ways to do that is to encapsulate those business rules inside of a series of classes. And some of those classes will represent tangible things, and some will represent intangible things, that maybe a process or even a computer-related resource, like the network or some type of other component that you have inside your organization. And so how do you make that switch from a tangible or intangible idea to code that represents that idea and gets work done as a result? Well, one known process that helps you break down a real-world problem filled with tangible and intangible ideas is called object-oriented analysis and design. Now, unfortunately, that's not something that we're going to cover in this series of videos, but again, I think you're going to be able to find a lot more information about that on Channel 9, on Microsoft.com, on my site, in books, and other places. So just to give you a jumping off point, you can look that up online. Okay, so to recap, a class is a data type in .NET, similar to those basic data types that we've been using, like string and integer. We also compared a class to a blueprint. You use a blueprint as the basis to create instances of a given thing, instances of the class. You define a class by defining its properties and its methods. You create instances of the class, and those instances are called objects. You create them using the new keyword, like we did right here. Okay? And there's still quite a bit to say about classes, but we'll pick up where we left off here in the next lesson. Be sure you watch it, and we'll see you there. Thank you.